Today's session chairman, Mr. Sushil Sharma. He is a chemical engineer. Currently, he is active in the IF. He is the honorary secretary of the National Council. He has developed color-changing coatings and foundry chemicals for Indian foundries and overseas market. Has presented technical papers in national and international levels. So I welcome Mr. Sushil Sharma and request him to start the session.
Hey. Hello. Good morning, everybody. Thank you, Sureshji. Well, today's first paper is presented by Mr. Anil Patel, who is Plant Manager, Vehicle Assembly and Engine Plant, Ford India Private Limited, Sananand, Gujarat. I welcome you, Mr. Anil Patel. His topic is Future Trends of Castings and Area of Opportunities. I will just brief you about himself. He is an electrical engineer from MS University, Baroda. He is a consumer-driven Six Sigma Belt certified professional by Ford Motor Company. Has experience in setting up and operating greenfield plants. Has worked in Ford plants in UK, Australia, China and Thailand on various production activities. Has received many global diversities and inclusion awards. I welcome you, Mr. Patel, and you can start your presentation. The presentation time is 20 minutes, and then we will be having a question answer session from the audience. Thank you. From the podium.
My presentation. Where is my presentation? मुझे पता नहीं है. I have sent it earlier. मेरा presentation इसमें होगा.
You can open your PPT slide, whatever it is. You have brought your pen drive?
No, sir. Actually, everything we sent in a mail.
Sureshji, there is some technical issue. Can you please come over? Hello. We are extremely sorry for some technical issues. So we are skipping Mr. Patel for his presentation, and we are starting with which one yours? Yeah. We are starting with the next speaker, Mr. Deepak Anagan, who is engineer in R&D department of Metso India, Vadodara. His topic is environmental effect of foundry operations and technological solutions. May I request Mr. Deepak to start his presentation? Yeah. Thank you.
Hello and good morning, everybody. First of all, I would like to thank you, Indian Foundry Congress, for providing us the opportunity for the presentation into this stage. Our today's topic is environmental impact of foundry operations and the technological solution for its mitigation. Let me start with our company introductions. We are from Metso Autotech, which is Finland-based multinational company having two foundries in India. One is in Ahmedabad, which is in operation since last 25 years. While second one is in Vadodara, which is in operation since last 2 years, and which was totally greenfield projects. Vadodara foundry having a capacity of 2,000 metric ton manganese steel casting per month. While in our Ahmedabad, Metso Autotech foundry mainly produce pump casting as well as the metallic mill liner. And apart from this, few percentage of the casting they making for the manganese steel. So this is a bird eye view of our Vadodara foundry. So let me introduce myself. Myself Deepak Anagan. I am working as a R&D engineer in our Vadodara units. So this presentation will be presented by myself along with Darshan Vyas. So first half I will present and then Darshan will continue. So let's start with the introduction. We all are aware that the foundry industry is having many processing from starting of the pattern making to casting dispatch, and that all the processes involve some kind of the processes and that impact environment. For example, melting furnace fumes, grinding dust, as well as when we dump that use sand that create the pollution into the environments. Paris Agreement was held few years ago, and during that all of the members are committed to reduce their carbon output as soon as possible. Apart from that, they also committed to keep global warming well below 2%. So to achieve this target, what foundry industry can do is they can use they can use latest technological solution available in the market. So let's start with the what are the processes which causes the detrimental impact on the environment. So one of the processes is molding and core making. If we see in the green sand molding, there are a lot of dust as generated. And in case of the resin bonded processes, variety of resin and catalyst use. And when we dump that sand, that is harmful for the our motherland. So it's create soil pollutions. After the molding process, if we talk about the melting process, and we all are aware that this process is very energy extensive process, and lots of energy are required during this process to melt the raw materials and scrap. and during the melting process itself, a huge amount of fumes are generated. In addition to that, before the melting, when we do the scrap cutting by any thermal means, that also creates the very tremendous amount of the fumes, and that need to be captured by any means to avoid its contamination to the environment. If we move forward, knockout and shake-out processes also create lots of dust lots of dust in the foundry, and we are all aware about that the environment at the area of the knockout and shake-out area. That generate very intensive noise, and same has been with the machine where the mechanical vibration is used, which creates also noise pollution. Apart from this both process, the fettling and finishing process also create or generate few amounts of dust. So here we have summarized the type of the pollutions and the what processes are involved to impact to the pollutions. First is the dust, as I already discussed earlier, that it is created due to melting, knockout processes, shake-out processes. Apart from that, that movement of scrap, furnace charging, and shake-out, all the process generate the dust. Also, the pneumatic transfer of the sand, that also create the dust. If we talk about the fumes, obviously the scrap cutting activity as well as the melting activity also generate fumes. Apart from that, when we transfer the mold and when we pour the casting, at that time the fumes are also created. The third one is the odor. It is generated in the casting and mold cooling, as well as during the sand mixings also it is generated. During the melting activity and spraying and the coating activity, the odor is generated. The next one is noise. The noise is generated, as we discussed, during the knockouting and shake-out machine operations. Apart from that, we know that the high frequency induction furnace also creates some noises, and short blasting booths and overhead cranes are a few of the sources of the noise pollution. The fifth one is the water, that water from the cooling towers, as well as where the foundry treatment process is water quenching, and that water is also creating the pollutions. Here, right hand side, the pictures is like fumes generated during the scrap cutting processes in the foundry. So this was overall the process that involves and that creates the trouble for the environment. I would like to draw your attention toward the latest technology that can help us to minimize its impact. The first is in the molding area when we use the sand. The first of all is recycling and reuse of the molding sand. In today's modern foundry is tremendous pressure, not only for the reducing cost, but the laws related to environment getting very stricter, and that trigger for the foundry to invest for the reclamation of the sand. Nowadays, most of the foundry is having the mechanical reclamation, but now foundry can use the thermal reclamation unit to reuse maximum amount of the sand into that foundry, so they can minimize the use of the natural resources and they can reuse it very well. In thermal reclamation process of the sand, most of all the binder and all the organic materials are removed by the oxidation process in the chamber. First, the sand coming from the mechanical reclamation plant passes through the cleaning tower, and at that time most of the metallic particles are removed before it's entered to the thermal reclamation unit. So the thermal reclamation system itself fluidized bed design with a gas and mixture, providing the fluidized medium and ignite on the sand bed via gas nozzle, and the typical thermal reclamation system are using in natural gas or LPG, and it operates at a different temperatures depend on the binder is used. So this is a very important technology. By using this, we can reduce the use of the sand, and we can also save the environment. The second one is a fume extraction system. Here we can see the old-fashioned extraction system some of the foundries using, and that metal melting process generate the gases fumes like contain very harmful element of gas. Apart from that, very fine particle of the solid component is also generated during the melting process itself, and that need to be captured by uh, any method or any technological solution available in the market. So nowadays, most of the furnace, if you buy new furnace, as equipped with the removable lid, and that furnace operates in a two mode. First, when the lid is open, most of the melting happen that times, and that furnace operates as the minimum exhaust power, and that lid is removable. So when that lid is open, furnace operates at maximum exhaust power, because at that time most of the fumes need to be captured. Here, right hand side, the picture of the fume extraction system we have installed in our Vadodara foundry. Once the fumes is extracted by the system, it's passed through the filter bag, and after that the filter air is passes through and released via the chimney. Here, the right hand side pictures from top of the chimney, the fresh air after the filtering is passes through. So now onwards, Mr. Darshan Vyas will be explained. Thank you.
So thank you, Deepak. Hello everyone. Myself Darshan Vyas, and I am working at Metso Autotech as a HSC officer, and my education qualification is I am pass out my BSc in chemistry, MSc in environmental science and technology, and post diploma in industrial safety from Gujarat Safety Council. So fumes are very high priority topic. Fume generation is very high priority pollution control for our foundry unit. So as Mr. Deepak announced that we installed fume extraction system with bag filter. Various new technologies are in market. So we installed recently new technology which called reverse air auto cleaning bag filter fume extraction system here. So apart from this, dust is also one of the major factor we have to reduce at our molding area, checkout area, and also reclamation unit. Also during sand transferring by pneumatic process or old conveyor system, many of lots of dust generated during this process. So dust we can provide dust collector. At Vadodara Foundry, we also installed various areas dust collectors, small and large dust collectors are provided. Also, these dust collector systems work by drawing the dust and particulate matters like PM10 or PM2.5, and it filters through filter media, bag filters, and separate the particulate matters and discharge purified air back into the environment. So in the dust collector, basic components are blower, dust filters, bag filter, auto cleaning system, and dust removal system. In foundries, dust collectors can be used at many places like I explained earlier, at molding area, reclamation unit, mixer area, shakeout area. Also we can put at fettling area for grinding dust control, we can put dust collectors. Also at fume generation at gouging and welding area, we can provide fume extraction system. Portable fume extractors are available in market, so we can reduce fume as well as dust from this technique. Another one area of concern is water pollution. At many chemical industry as well as foundries are generated, we generate lots of water effluent. So we can treat our water effluent at two major part of the treatment plant that called as a effluent treatment plant and sewage treatment plant. So at Foundry, we have zero water pollution policy. So we installed SCP sewage treatment plant to reduce and recycle water of domestic water which can generate from canteen, water bath area and also at toilet area. So first water is collected at soak pits and after that by gravity it will come at STP plant and we have primary, secondary and tertiary treatment at STP plant. After that we will recycle our water at for development of garden and green belt. Also we can use RO reject water which is having high TDS in nature. So we are using RO reject water in our quenching media at heat treatment process. Also wastewater from domestic supply can be recycled and used for gardening, and by doing this we can reduce the water usages as well as pollution. Many other new technologies are in market like energy efficient equipments are available with latest technology like Foundry need to adopt those technology to reduce energy consumption. Ultimately it will reduce the impact on environment. For example, there are high efficiency burners are available for complete combustion of LPG as well as PNG gases in heat treatment area. In addition to this, some of the foundries use the refractory coating on heat treatment furnace lining. This coatings has very low thermal conductivity, so it will reflect back heat back to the furnace. It will reduce heat losses, also it will reduce LPG gas consumption. Apart from this, Foundry need to adopt new green renewable energy concept. So we can install solar panels as various our Foundry premises where direct sunlight comes. Electricity generated from solar can use in the office area as well as we can use for shop floor lighting. So here right hand side we can see at our parking area on top of the shade we installed recently we installed 60 kW solar panel at parking area. Also we have planned to install 2 megawatt heavy solar system on our production shade. So apart from this we can use LED lighting instead of normal lighting. That will also reduce our energy consumption, and not directly but indirectly we can contribute to minimize the CO2 emission which will generated at various power plants and electrical sector. Apart from this, we can commonly use one common concept of rainwater harvesting to limit the water uses. So now we installed various technologies, but if we cannot measure with pollution factors, so we cannot minimize the pollution source. So we at Metso Autotech we monitor ambient air quality monitoring following by the methods of PM10, PM2.5, sulfur dioxide and oxides of nitrogen. At stack monitoring we also monitoring particulate matter, sulfur dioxide and oxides of nitrogen. Also for sewage treatment plant which we are using at gardening area, so we have to monitor biological oxygen demand, total suspended solid, pH and residual chlorine. to minimize the environmental impact on ground as well as biota. So workplace monitoring also done, in which we are monitoring total dust, sulfur dioxide and nitrous oxide. Drinking water as well as noise monitoring will done by this standard.
Mr. Darshan, last 2-3 minutes.
Yes, sir. So we can conclude that it is observed that proper use of engineering solution and latest technology, adverse environmental impact of foundry operation can be reduced. Here the most of the solutions are presented, very commonly used in almost new foundries, but foundries should do continuous monitoring and measurement to reduce its impact on environment. Additionally, time to time maintenance and preventive maintenance is required for effectiveness of this equipment and technology. Also, foundry industry need to work more intensively towards waste recycling and adopt new green energy technology like solar panel. Thank you very much.
Thank you. Thank you, Mr. Darshan and Mr. Deepak. You can have the questions. We will have 2 to 3 questions from the audience. So if you are having any queries, you can ask to the speakers. May I request those sitting at the back, please come in the forward front seat so that you can see the slides in a better way. Any question? Mr. Darshan, I have got one query to you. You are from Metso, Vadodara.
Yes.
Okay. Your foundry is the Alpha Set foundry. Am I correct? You have covered many aspects of the pollution and the environmental effects of the foundry operations. One aspect you have not covered. I think in Metso, Vadodara, you are using the solvent-based coatings.
Yes, sir.
So when we are burning these solvents, there is many organic gases getting involved.
Yes, sir.
So how you are taking care for such kind of environmental impact? Can you explain?
Sir, so nowadays many green sand technologies are available in market. So we are taking trial and we will definitely move that technology in future. But continually we are monitoring VOC emissions from sand and coatings. So we are working on that. But after getting positive result, we will explain in better way.
Okay. Thank you. Definitely we need to make our foundry as green as possible.
Yes.
That is the today's requirement.
Yes, sir.
Well, thank you very much.
Thank you, sir.
Yeah. Mr. Suresh, can we have the memento for the speaker?
Good morning, everybody. Topic of my presentation today is the future trends of casting and area of opportunities. Over last 2 days, all of you would have got a lot of insights about castings, manufacturing processes. So I'm going to keep my presentation and the topic succinct and simple. So I would like to thank the organizers for driving the conversation on future trends in casting in this Industry Foundry Congress 2022. Today I would like to focus on the topic of quality and delivering zero defect in manufacturing of casting industries. A lot of presenters at this forum have already spoken about organizational, cultural, achieving excellence, implementation of continuous and breakthrough improvement, and total quality management, including some of the intelligent systems and the environmental topics. Why quality is important? And delivering of quality, excellence quality, required all of the things what you have gone through and more, pull together a sustainable plant operating systems that is unable to continually evolve with the ever rising expectation of the customer. Clearly, if we want to make in India for India and export to the world, we need to deliver quality at the level of demanded by the toughest customer. And today I'm going to cover some of the topics which can be useful. Along with this, I'm going to cover auto industries in India. I'm not here to answer the question about, Ford's future in India. I'm here only to talk about casting and in general auto industries. And what are the critical to quality expectations from foundries? So auto industry contribution in past close to 8% of GDP as per 2019. 19 million people are being deployed, and a lot of recent announcement includes 100% FDIs and recent announcement of a PLI of EV industries are the lucrative futures for auto industry in India. In India, we have got 5 regions, all of you know, and the expectation of this industry will go to 300 billion by 2026. This is very interesting. Auto industry has seen up and down since it started, but 2016 and 2017, we had a golden era where you see upscales. And if you look at the linear scales, the industry is progressing in a positive direction. Research from Counterpoint suggests we had a CAGR low, but if you look at third best year in 2021, after 16 and 19 was 21, over 3 million units of passenger vehicles were sold. So again, a great future ahead. This is from CRISIL. The way you read this chart is, this was a survey done by what is the customer expectation and what do they think about demand bounce back, and this was done back around a year back. So construction and the real estate, the circle indicates 40%, the red dark indicates above 40% responses says that is 46%, that demand will bounce back. 21% to 40% responses says Q4 2021 it will bounce back, and 33% said it will bounce back in 2022. Look at carefully the auto components, commercial vehicles, 50% demand will bounce back in 2022, and passenger vehicles, financial 2021, 48%. And we saw that 30 million vehicles sold, right? So it's, and remaining 30% will grow. The two-wheeler industry had a great turnaround in 2021. Coming back closer to the casting industry and specifically to aluminum, electric vehicle cells, now this is about EV, not ICE. EV demand is going to exceed 40 million by 2030. And if you look at aluminum demand for EV specifically, 2025 to 2023 upswing, which is quite significant. And this is already happening. If you look at other part of the world, Europe, North America, China, technologies are improving. The old foundry technologies are going out and the new foundry technologies are coming up. So this is what is happening in other part of the world, as well as OEM investing heavily on the electrical vehicles. What's the future? Casting industry for automobile, when one speak, it's about 4 components historically: head, block, crank, and gear case housing. But from present to future, if you look at electrical vehicles has got significant increase of the aluminum die casting, high precision aluminum die casting. It includes e-motor housing, battery housing for plug-in hybrid and battery electrical vehicles, and fuel cell housings. Interestingly, lot of body component, where we see a sheet metal now, are also getting changed to complete aluminum die casting. So if body in white, the shock absorber, mountings, the rear rails, A-pillars, from the driver's seat is left and right A-pillar, B-pillar and C-pillar, the full subframes and the cradles where batteries and the transcasing is mounted are also getting developed towards lightweight casting. And this is a significant step change from where the casting industry is to get ready for the future. Because a lot of talks about if internal combustion engines gets out, what's the future of casting? But this is a future. Some of the examples of high precision aluminum die castings. So the right-hand side picture is about the front cross member, where actually the powertrain component sits, and the shock absorber tower, and the rails. These are all built with aluminum die casting. So you don't have to manage complexity, don't have to manage welding parameter, etc., etc. And it is a lightweight, which improves the emission as well as the strength to weight ratio, fuel efficiencies. To deliver this, what are the critical to quality parameter? So if you look at input, in foundry industry, temperature, velocity, pressure, and solidification, these are the critical input parameters. When we talk about SIPOC, right, it's all about how you measure your input so that your output is predicted, good or bad. And when bad is prediction, we do correct so that the customer don't get bad quality. If it is not managed well, impact to product quality defects, all around hot tier, cold certs, these are all foundry terms, so I'm not getting into detail. And it costs a lot to the foundry as well as the OEM. Control measures, what we can put in place is the feeding systems, thermal balancing, real-time process monitoring, AI technologies, and automatic detection of the process parameters. So if anything goes wrong outside the control limit, the process stops producing bad quality part. What can be done in a pre-advanced stages is about simulation, flow, magnaflux, some of the die enhancement plant, surface treatment, AI cameras, vibration monitoring, heat temperature monitoring, etc. When things goes wrong, it's a major cost to the company, including OEM as well as the foundry. and it calls recalls, bad brand images, etc., etc. So if we have to get out of this, I think the way is to focus on input and have a very solid quality process control. Getting further detail, the expectations from the foundries. So it categorized in 4 different categories: material, sand management, tooling, and simulations. And further down, there are various methods available for material, raw material check about radioactivity. If we have a separate grades, identification of the grade by material, so you can prevent the mix. Spec for raw material, very control, and in-house spectrography, so that you can do very quick check, audit of the raw material. Sand management labs following the American Foundry Society standards for grain finishes and checks, and sand reclamation and recycling, including environmental friendly processes. Tooling, in-house local tooling, geometry check, time to time, always have a backup of the dies, and very solid die prove out and product launch process, and for the complexity casting check process. And simulations, actually many foundries does the simulation as a part of product launch because that's a customer requirement. But then when things goes wrong, going back to simulation and understanding whether that was done right or wrong and what improvement needs to be done is a key area of gap. And that only comes when there is a problem. So key area of opportunity is there. When we talk about quality, very close to personally me, this is what it is, right? When nobody is saying, doing the right thing is about quality. Very interesting chart here. And this actually signifies the cost of poor quality. So far left is the customer. And then start with the tier 3 sub-supplier. What you see, the red walls are the quality wall and checks. As we get closer to the customer, the wall get reduced. So our opportunity to detect the defect get actually reduced. And below, the cost of poor quality multiplies, sometimes 1,000 times. So if there is a porosity in the casting and there is engine change, right? The complete engine change gets to the foundry. Now if you have complete process parameters, temperature, process, all those parameters checked and controlled, you can detect this, right? So that you can stop producing bad quality parts. So cost of poor quality significantly increase as the bad defect goes to the customer. And finally, measurement of the quality. Everybody likes higher numbers of the FTT. And this slide is very interesting. If you look at the top side, if you have processes in casting, you have a step A, step B, step C, steps D, and if you have a very good check about what you are putting in, what you are getting it out, and then do the roll throughput, that's a real measure of roll throughput. Rather, putting 100 parts, get 90 parts out okay, you say 90% FTT, but that's not the case. For the similar process, if you apply roll throughput, it will be 79% because you are spending energy, labor, everything to process it. And whatever is in process rejection is cost and a waste. So this is where you may want to think about how you want to rejig the measurement of quality in our processes. So with that, I would like to conclude and thanks IFC 2020 team for giving me this opportunity to share my thoughts about future trends in industries and expectations from foundries. Thanks very much. Namaste.
Hello. Thank you, Mr. Patel. Anyone having any questions, queries to the speaker? Yeah, please. Can we have the mic for the person?
Hi, good morning. I'm Tanay Anjikar. I would like to ask a question that our speaker, Mr. Anil Patel, he majorly spoke about die casting. I just wanted to ask what would be the scope of investment castings in automotive moving forward?
I think, yeah, so I think investment casting, precise small components also has got a future. But if you look at the die casting has got a major feature in the industries as we go towards the EVs. Die castings are very, very limited right now. Small clamps, etc., high precision in investment casting. But the major feature is on the die casting, the major components. But but clamps on the batteries, for example, high precise can be opportunity for investment casting.
Thank you.
Anyone else? Yeah, please.
Good morning, sir. My name is Imtiaz Ali. I just want to ask you one thing. In your views, Industry 4.0, artificial intelligence, IoT, how does this thing can help to improve the quality?
Yeah, very good question. Thank you, Imtiaz. I think uh, Industry 4.0 and big data analytics, in my view, it can tremendously help the industry if there is a thinking behind what actually we want to achieve. And the reason I say this, nowadays there is a big push about data collection, data gathering, and there is a tons of data, thousands of dashboard. But actually we need a humanware to interpret those data and make the right decisions. So any Industry 4.0 application, I would ask what ultimate benefit it is going to give me in my operation. Is it going to improve my quality, reduce waste, improve the cost, and do I have a sufficient members who can interpret and analyze the data and make the real-time decision, right? Because manufacturing industry follows the tech time. One day delay, opportunity loss. So yes, it has got a lot of benefit using various cameras, the thermal monitoring, predictive technology, connecting machines. A lot of data can be made available, but setting the right baseline, right? And identifying the outlier and working on that is a real uh, uh, effective use of Industry 4.0.
Thank you. Very well explained. I hope your query is sorted out. Anyone else? We can have the last question. If anyone is having. Well, thank you, Mr. Patel, for your presentation. Can we have the memento? Mementos, please, ma'am. Hello. Well, the next speaker is Mr. Aditya Karivartharajan. He is a senior engineer metallurgy from R&D department, PK Steel Castings, Coimbatore. His topic for today is amalgamation of metallurgical theories and foundry traditions of ASTM A995 slash 8995M super duplex stainless steels. He is a postgraduate in metallurgical engineering. He is a ISO 9001-2015 lead auditor and ISO 17025-2017 internal auditor. Has published many papers and written monographs on metallurgical topics. He is an international technical member of IFEX. Over to you, Mr. Aditya. You can have your presentation. Thank you.
So good morning. Thank you, sir, for your introduction. So today I am planning to discuss about the amalgamation of metallurgical theories and foundry tradition. So why this topic of amalgamation? Because basically the metallurgist, including me, we speak lot of theories. But when it is coming to the applicability in the foundry, we have lot of doubts how to interpret the theory and the practical things. For example, we will have a cardiologist, he may have 100 patients. So 100 patients' health condition will be different. 100 different situations. So that particular doctor has to analyze each and every patient and should study their own patient and have to give the solution for them. So similarly, a metallurgist in each foundry, we have 100 number of foundries and 100 foundries have 100 different parameters. So we have to understand first our own foundry and we have to mingle our metallurgical theories with that particular foundry's practical situation. And why this ASTM A995 super duplex stainless steel is because now the entire industry is turning from super austenitic stainless to super duplex stainless steels because of their enhanced corrosion resistance along with the mechanical properties. So today we will see just about duplex stainless steels and what is the metallurgy of duplex stainless steel and the characterization of duplex stainless steel using various methods like metallography and XRD analysis and SEM and EDS analysis and interpreting various phases that are forming, and we will see some conclusions out of that. So basically duplex stainless steel is a family of stainless steel. It is a bridge between austenitic stainless steel and ferritic stainless steel. So this material basically contains 30 to 60% of ferrite phase and remaining austenite. And it has an excellent corrosion resistance for stress corrosion cracking due to presence of ferrite. However, the same ferrite makes the material susceptible for hydrogen-induced cracking. So this material is particularly restricted beyond the application of 350 degrees Celsius because of formation of various secondary phases that we will see in the upcoming slides. So here we can see a graph which is showing different kinds of stainless steels that we produce, where the if you see at the top, we will have austenitic stainless steels which is mentioned as A, and at the below right column we will have F, which are ferritic stainless steel. And we can see the ferrite content A plus F at the right corner, which indicates the percentage of austenite and ferrite wherever duplex stainless steel belongs to. So the solidification of duplex stainless steel is a typical solidification which is entirely different from all the other steel materials, including carbon steel or stainless steel, even austenitic stainless steel and ferritic stainless steel, because in this the solidification starts with ferrite phase followed by austenite transformation below 1000 degrees Celsius, and the advantage of duplex stainless steel is that we have addition of nitrogen. So this addition of nitrogen actually promotes the nucleation and growth of austenite phase in the material at high temperature, and during solidification there are various phases that forms, unlike austenitic and ferritic stainless steels like nitrides, carbides and lot of intermetallics. So this is the solidification pattern of a normal stainless steel based on the chromium and nickel equivalent, as we know. So discussing the solidification of duplex stainless steel, which is drawn by the blue line, we can see the solidification starts from liquid. So once the material reaches around 1500 degrees Celsius, the solidification starts, the liquid transform to liquid plus alpha. So below 1450 degrees Celsius, we will have 100% alpha, and on further solidification and further cooling process, the new phase, that is austenite, starts to form. And this continues up to 800 degrees Celsius, and at 800 degrees Celsius, the third phase starts to form, which is the sigma phase. So the 850 is the degree Celsius where it starts with sigma and continues the formation of various phases like psi phase, nitrides, carbides, G phase, R phase, n number of phases starts to form. So you can see this is a typical TTT diagram of a duplex stainless steel where we see n number of phases, not like the other steel that is chromium carbide, sigma phase, psi phase, nitrides, secondary austenite phase.